बिस्मिल्लाहिर्रहमानिर्रहीम काला रब्बि इश्रह ली सदरी वयस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली. Assalamu alaikum. Today we are going to discuss about trace of a matrix and some of its basic properties. First of all, what is trace of a matrix? If A is a square matrix of order n cross n, then trace of A denoted by TR of A is the sum of all the elements in the main diagonal. Mathematically, we can represent it as trace of A is equal to summation I from 1 to n ai. आई मीन सेम इंडिसेस जो हैं ये मेन डायगोनल के एलिमेंट्स को रिप्रेजेंट करते हैं और जो समीशन है ये उनके सम को रिप्रेजेंट करते हैं. Trace of a matrix is also called spur. It is noted that if A is not square matrix, then trace of A is not defined. That is, we can say that trace of A is undefined. For example, if A is equal to 3, 1, 2, 2, 0, 0, 1, minus 1, minus 2 is a 3 cross 3 matrix, then find trace of A. Trace of A is equal to sum of the all the elements of the main diagonal, which are 3, 0, and minus 2, and their sum will be equal to 1. Another example, if I3 is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1 is a matrix of order 3, you can say 3 cross 3 or simply 3, then find trace of I3, which is equal to sum of the diagonal elements, which are 1 plus 1 plus 1, which is equal to 3. Now, its basic properties. First property is that trace of A plus B is equal to trace of A plus trace of B, where A and B are square matrices. Second property is trace of C times A, where C is a scalar and which is equal to C times trace of A. Third one is trace of A is equal to trace of A transpose, where A T represented transpose. Property number 4, if A and B are two n cross n square matrices, then trace of A transpose into B is equal to trace of A into B transpose, which is also equal trace of B transpose into A, and this result is equal trace of B times A transpose. Number 5, trace of A into B is equal to trace of B into A, B into A. You can say that commutative law with trace is hold in matrices, but simple commutative law is not hold in general or in matrices. Number 6, cyclic property. If we preserve cyclic order of the matrices, then its trace always equal trace of A, B, C, D, which are in anti-clockwise rotation. A, B, C, and D is equal to trace of B, C, D, and A, which is equal to trace of C, D, A, and B, and this result also equal to trace of D, A, B, and C. Next result is that trace of A, B, C is not equal to trace of A, C, B, because in this case cyclic order is not hold. We can see A, B, C is in cyclic order, which is represented left hand side, and on the right hand side A, C, B, which have opposite direction to A, B, and C. That's why these results are not equal. Next property, number 8. If A is a symmetric and B is a skew symmetric matrices, then trace of A into B is equal to 0. Number 9. Trace of AB not equal to trace of A into trace of B. Number 10, trace of identity having order n is equal to n, where n is the order of the identity. Second last property, number 11, the trace of an idempotent matrix, which can be defined as if A is any matrix, then A square is equal to A, means A is called idempotent matrix. is equal to rank of A. Last one is the trace of nilpotent matrix is always 0.